Welcome to Pomodoro Joe for Tuesday, May 2nd, 2023. Today we're doing LeetCode problem 1822, sign of the product of an array. This is an easy problem. There is a function, signFunc(x), that returns 1 if x is positive, -1 if x is negative, and 0 if x is equal to 0. You are given an integer array, nums. Let product be the product of all the values in the array nums. Return signFunc product. And then they have some examples. All right, so this one's pretty straightforward. I think the only things that we really need to note are how do we end up with a positive product, a negative product, or a 0 product. All right, so for a positive product, well, if we have a positive number times a positive number, that will always give you a positive number, no matter what. If you have a positive number, but you multiply that by a negative number, well, then that's going to end up giving you a negative number. If you have a positive number, well, actually, we've already done that. Let's go to our negative numbers. If you have a negative number times a negative number, that will give you a positive number. So a negative times a negative is a positive. So that's our key insight on this one. And finally, how do you get 0? Well, no matter what you have, if you have a positive, if you multiply it by 0, you'll get 0. And if you have a negative and you multiply it by 0, you will get 0. So these are all of our options. Two positives make a positive. A positive and a negative make a negative. Two negatives will make a positive, and anything times 0 will result in 0. So really what we need to do here is just go through. If we find only positive numbers, then it's going to be a positive number. If we only find negative numbers, well, then we have to keep track of the negative numbers because this will be flipping back and forth. If you have a negative times a negative times a negative, then that will flip it back to a negative. So basically we need to count the negatives here. If we only have positives, we'll end up with positives. If we have positives and negatives intermixed, then we need to count how many negatives we have. So if we have an even number of negatives, it's going to result in a positive. If we have an odd number of negatives, it will result in a positive times a negative, which will result in a negative. And if we ever run across a 0, we'll return 0. Okay, so with that, we will put 25 minutes on our Pomodoro timer and get started. Okay, because our result really only depends on how many negatives we have, and in fact, it only depends on if we have an even number or odd number of negatives, we can just keep track of do we have an even number or odd number of negatives so far. So our result will start out as, we'll just start it as 1, because that's going to be our default. If we just have positive numbers, we'll end up with a result that's 1. And at the end, we'll return our result. All right, so then for every number in our nums, let's check to see if this one is positive or negative. If the number is negative, so less than 0, well, let's see. We could keep track of how many negatives we have, or we could just flip our result from being whatever it is now to being the opposite. So if it's a negative, it'll become a positive. If it's a positive, it will become a negative. So let's do that. So our result at this point will just equal -1 times our result. So if our result is a positive number so far, and this number is a negative number, then our result will become negative. If our result was a negative number so far, and this is a negative number, then our result becomes a positive. So it turns into positive 1 here. And if we ever get a 0, then we'll just return 0. All right, so I think this should do it. All right, we start our result as 1. Then we'll go through for every number in our nums. If we find a negative number, we need to flip our result from being a positive to a negative because we're multiplying by 1 more negative. If we ever run across a 0, then we return 0. At the end, we return our result. So let's check this out. And that works. Let's see how we do. And we pass, and we do quite well, actually. I'm kind of shocked. We beat 93% for runtime and 7% for memory. That's not bad at all. All right, I I probably can't improve on this at all, but I'll show you one other thing we could do, but we probably don't want to do it this other way, but I'll show you anyway. All right, so instead of having our result here, we'll keep track of our count. Let's say negative number count. Start it as 0. Anytime we get a negative number, we'll just increment our count. If we ever run across a 0, we'll still exit with our 0. Now down here, instead of returning some result, we'll return count mod 2. So not quite. If you do count mod 2, this will tell you if it's even or odd. If this is even, this count mod 2 will be 0. If it's odd, this count mod 2 will be 1. So modulo 2 is basically saying, what is the remainder if I divide count by 2? So if it's an even number divided by 2, there is no remainder. It's evenly divided by 2. If it's an odd number, then the remainder will be 1. So we can say we'll return -1 if count mod 2 is equal to 1, else we'll just return 1. All right, so this should do the same thing. We're just keeping track of the count of odd numbers. If it's odd, then we return -1. If it's even, we'll return 1. And if we ever run across 0, we return 0. All right, so this passes. It doesn't do quite as well. We only beat 66% for runtime and 7% for memory. So it's not quite as efficient as our previous solution, I think because we're doing the same thing. Essentially, we have one operation per loop, where in this case, we're adding 1 to our count. In the previous solution, we were multiplying our result by -1, potentially. But at the very end, the main difference is we do have to do this modulo operation, which takes a little bit more time than simply just returning the result. All right. So that's it for me. This one's pretty simple. There's a lot of different things you can try with this, or different things you can play around with. So check it out. See if you can do better than, what did we get? We had a 93%. Yeah, see if you can beat that. I bet you can. All right, hope you enjoyed this. Hope you had fun. Hope you learned something. Hope you can go out and write better code.